This is gyroscopic procession, and we're going to explain it without using any math. Are you ready? Let's do it. Let's start by remembering that velocity is the speed at which something is going, and acceleration is the rate at which that speed is changing. So, to go from no velocity to some velocity, the object has to accelerate, and to go from some velocity to no velocity, the object also has to accelerate, but in the opposite direction. Now we can say that force is a push that something needs to accelerate. And now we have two weird ones, angular acceleration and angular velocity. They sound scary, but they aren't. They are basically the same thing, but they describe motion in circles rather than straight paths. And finally, torque, which is basically a force applied at a certain lever arm. You can see it by pushing a door from different points and seeing further from the hinges, that is, having a larger lever arm makes it easier for you to push the door. Therefore, the larger the lever arm, the larger the acceleration. So let's look what happens at the center of the gyroscope, and then we'll observe what happens at the pivot point, in this case, the contact between the gyroscope and the string. We'll use arrows to show us which way stuff is going, and the size of the arrows will tell us how much of that stuff we have. Since things are happening in all three dimensions, we'll be using 3 points of view: the front, the top, and the side. First point. At this point, we have a lot of angular acceleration, since gravity is trying to pull the gyroscope like so. Therefore, this point will be accelerating like so. However, we don't have any angular velocity just yet, since the gyroscope had no time to accelerate. Second point. At this point, we have a smaller lever arm for gravity to pull on. Therefore, we have less acceleration. Also, notice that we do have some angular velocity right now, since we had time to accelerate. Third point, same logic. Please notice that at both of those points, our velocity is not only downward, but also to the right, since our velocity is not on this axis or this axis. Therefore, the velocity from here can go this way and this way. Fourth point, right now we have no angular acceleration, since there is no lever arm for the force of gravity. Also, we have a lot of angular velocity. However, it all goes to the right, since now the point is on the axis. Fifth point, our acceleration is in the opposite direction, which makes sense since gravity is pulling the gyroscope like so. Therefore, this point will be accelerating like so. Actually, the entire bottom part of the gyroscope will be accelerating this way. Also, at this point we have less angular velocity than we had before. That is because the acceleration is in the opposite direction. Sixth point, same logic. Notice that at both of those points our velocities were not only to the right, but also upward, since it's pivoted right here. Therefore, velocity from here is upward and to the right. Also, notice that the velocities downward for the first quarter of the motion are cancelling out with the velocities upward from the second quarter of the motion, and therefore our gyroscope only moves to the right. Seventh point, no velocity. It all cancelled out due to the acceleration in the opposite direction. Now, to make things a little easier for us, I will rotate the gyroscope and we'll be looking at the back of it. Notice that our velocity to the right remains to the right, since from here it will be going that way. Also, notice that the second half of the motion is exactly the same as the first one. However, it's just upside down. Therefore, first point, second point, third point, fourth point, fifth point, sixth point, and seventh point. That means that our velocities up and down cancel once again, and we once again have only the velocity to the right. Therefore, our gyroscope moves only to the right for the entire motion. Well, those were the effects on the center. Now, let's see how the center affects the pivot point. Well, as you can see from the picture, our center wants to rotate like so. However, since it's pivoted right here, it can't just do this. It has to do this to rotate in that direction. And voila, we just explained gyroscopic procession without mentioning any numbers or Greek letters at all. Congratulations!